Welcome back to the Learning Curve video series. We're going on to talk about a specific application of Learning Curve. We're going to start off with this slide here that talks about a whole bunch of different applications for a Learning Curve. What is in bold, I feel like we've kind of referenced in the example problem that we went through and what we've talked about on prior videos. So if we know how steep or not steep, we just know what our learning curve is. We can plan for capacity, how many people we're going to need, how many pieces of equipment to get. For example, the first 60 units built was very different amount of time if we consider that labor driven for a 90% learning curve than for a 60% learning curve. Then we can also estimate the cost, because if it takes us over 1,100 minutes of labor to make the first 60 units, then we would need to incorporate that into our cost, which is what the next application, an example from Boeing I'm going to go over with you, versus if it takes a lot less than that, which is what it would with 60%, we wouldn't want to overcharge or be unfair in that aspect. Planning for our labor, how many people we would need to have there, etc., for that kind of thing. Okay, so you can look at this on your own and see how you think any of these apply to the learning curve within your project as well. So let's move on to an example from Boeing. I've had a guest speaker from Boeing come to my engineering economics class several times, and one of the aspects of his presentation, as he's explaining information for the engineering economics class, is the learning curve takes into account. So this is the information here is not actual data, but it's representative of what they experience. So he worked at a facility where they repaired equipment, repaired airplanes for the military. Maybe the Air Force, I'm not sure, but something like that. And so they would get a contract from the Air Force or a bid to do repair for X number of planes or for a particular type of plane or something like that without ever having the plane come in. They would have to bid on it to see if they were going to be the one that won the contract. So you can see that that might be a little disconcerting, because first of all, there's going to be all sorts of different types of repairs that need to be made, and how long they take is going to be very different too. So this is some information. They use cost, but you could represent this as minutes compared to what we did too. They represented this as cost. They estimated that it would take it would cost $1,273 for the first one. And then they made an assumption of a 93% learning curve. And where they made that assumption is based on empirical data from prior planes that were similar and the types of repairs that were made on that. So that was close to 93% or 93%. So that's one of the reasons they use 93% learning curve. They use subject matter experts. The SME is an acronym you'll hear thrown around in industry. But what people thought would be the time, in this case the cost to make the repair and how much improvement we'd be able to make unit over unit. Actual historical performance, which is kind of similar to the empirical data of similar planes, like repairs, and some statistical analysis of all that. So based on data that they had, they estimated that it was going to be a 93% learning curve. And their subject matter experts probably said, okay, well, this is going to cost this much for the first unit, or maybe theirs was after they got going. But anyway, subject matter experts, people who've been doing this kind of work for 20, 30, 15 years, whatever, for a long time. So you can see that we have the doubling impact here that we talked about earlier, where if we go from unit 1 to unit 2, 1273 times 93% learning curve gives us the cost, in this case we're using cost, of 1184 for the second unit. The second unit times 93% gives us the cost of 1101 for the fourth unit. The fourth unit times 93% gives us 1024 for the eighth unit. So you can just see that the doubling impact, doubling phenomena works regardless of what the learning curve is, that every time you double the units, then the cost, hours in the examples we did, but cost here is the learning curve times the original earlier unit. Okay, so this is actual data that they had in place and how they estimated what the learning curve would be and what their initial cost would be. And so based on this, again, they have to make the cost, make the bid for the work based on this information. So they made the bid based on that it would take 1,000 hours, $1,000 to complete the 10th unit as their point of bid based on the number of units they were going to get and that sort of thing. Okay, so then here's some actual data. We don't see the axis over here, so we don't know exactly what the numbers are, but this is actual data from their facility, and it goes across several years. And so you can see that it has some disruption, right? It's not a straight learning curve like we're used to seeing, a straight learning curve, because in actuality it's never going to be the theoretical numbers. It's going to, we'll do a best fit curve is how we'll figure that out when we get into lab. But he's identifying here that, okay, from the first few planes we had, this 3P is process, people, performance. I don't know, it's an improvement process that Boeing runs that got him here. But then the volume started coming in, and so they used standard work in 5S, which you learned about from our lean module earlier in the quarter. And then they had a little bit of an uptick, which is not what we would expect to see, and that was due to a shift in customer demand. Then they got the people involved, so that would be the +1, eliminating the +1 waste, right? Get people involved so that you use their ideas. And value stream maps, another concept that we did earlier in the quarter to see exactly what was going on and where any waste could be removed. And then that brought them back down to here. So you can see several things went into place in order to reduce, and then why the aberration of an increase happened was a shift in the demand, and then other things they did in order to bring it back down the learning curve, the time per plane. And so you can see he's showing here the standard work. This is the best fit line against that data, against the unit. So you can see here's the 10th unit is the 1,000 hours. We don't see the axis here, but the $1,000 hours, whatever basis we're going to use here. And you can see that's kind of close to where it's somewhat, maybe not, somewhat leveled out, but out of the steep part, in this case not so steep, but steep part of the learning curve. And so 5S we know about, they did in order to make some improvements here. Standard work operation, standard operating procedures, which we learned about early in the quarter. The supermarket is a way of managing inventory, and then the value stream maps and employee involvement to bring it down even more. So this would be, would you say that these value stream maps and employee involvement are worker contribution or company contribution? I would say company contribution, because they bring people together away from their day-to-day jobs to work on these things and make some improvements. So they probably took action as a result of this type of analysis that they did, which meant money and resources. So I would argue that these are company contributions to that. Okay, so that's the Boeing projected performance, so that you can see an actual example from an alumni from our Industrial and Manufacturing Engineering department. Next, we're going to move on to 2 additional videos where we'll have 2 different example problems. Thank you.